All right, y'all. The last lesson of Unit 5 is all about the quadratic formula. And this is one that you probably learned in Algebra 1. Oops, got my L in the wrong spot. But we don't teach it till last because, honestly, quadratic formula is meh. Let's talk about what we've done thus far in Unit 5 as far as solving quadratics is concerned. We've learned 3 ways to solve so far. Really, Smith? Yeah. First one that we did was solve by using square roots. Solve by using square roots. Let's do an example of that. Example of that would be 3x squared plus 5 equals negative 13. Go ahead and take a minute, solve that. Go ahead and press pause. All right, so you probably got 3x squared equals negative 18. X squared equals negative 6. Square root both sides. And whenever you use a square root to solve, you have to put plus or minus. Root negative 6, well, this root negative means an I comes out. X is equal to plus or minus I root 6. Those are our 2 solutions there. Good. Now, the thing about using square roots, we're only allowed to solve by using square roots only when there's only x squared, right? X squared by itself, that's easy to solve. But once you got x squared and x's, that's where it starts getting tricky. And that's when the next thing that came up was solving quadratics by not factoring, not even factoring, by factoring. All right, let's do an example of that. One of the examples that we did back then was 2x squared cubes, 2x cubed minus 4x minus 48 equals 0. Oh my goodness, I'm screwing this all up. I'm sorry, y'all. Here we're at. 2x cubed minus 4x squared minus 48x equals 0. My bad. All right, go ahead and press pause and solve this. Okay, so hopefully yours went smoother than my writing it. First thing, whenever you factor, first thing you look for is a GCF. 2x can come out, and you're left with x squared minus 2x minus 24 equals 0. Then what multiplies to negative 24 adds up to negative 2. Well, that's x minus 6 times x plus 4. Now, because there's 3 x's that are happening here, we expect to find 3 answers. So, set them all up as 2x is equal to 0, x minus 6 is equal to 0, and x plus 4 is equal to 0. So our final answer here would be x is equal to 0, x is equal to positive 6, and x is equal to negative 4. Those are our 3 solutions here. And then the last way that we learned to solve, our third way, was by completing the square. Completing the square. Let me come back to factoring here. Using square roots, only got to be x squared. By factoring's great and all, but not everything factors. Sometimes if you can't factor it, you're stuck. You don't have a way to solve it, and that's where completing the square comes in. Completing the square is great because completing the square can solve anything. X squared plus 9x plus 4 equals 0. Now, we can't use complete square roots because there's x squared and x. We can't factor because what multiplies a 4 and adds a 9? And that's right, a whole bunch of nothing. So we'd have to solve this by completing the square. So we'll do this one together. First thing first, get rid of the constant. x squared plus 9x, leave a space, equals -4. Now, there's not a leading coefficient, so we don't got to worry about that, but we still got to find half of b. So half of b in this case is 9/2. So, and then we got to square it, add 81/4 to this side, plus 81/4 to both sides. Then we got to factor this. This is x plus what multiplies the 81/4 and adds up to 9. That's right, 9/2. 9/2 quantity squared equals, what is 81/4 minus 4? Let's see. 81 minus 16. I got 65/4. You might want to go and double check me, but I'm pretty sure I'm right. Square root both sides, and you'll add x plus 9/2 equals plus or minus root 65/2. In case you're wondering, when you square root both sides, square root's the top and bottom, so square root of 4 is 2. That's where that bottom one comes from. Then you get x equals plus or minus, negative 9/2 plus or minus root 65 divided by 2. Completing the square. So like I said, we gave you the easy ones, then we gave you a little bit harder, but still easier, but it doesn't always factor. And then we came to completing the square, which always works no matter what the case is. All right. Smith talks for 10 minutes now. You haven't talked anything about quadratic formula. Quadratic formula is for any equation in the form zero equals ax squared plus bx plus c. Then, and here it is, x is equal to the opposite of b, plus or minus the square root of b squared minus 4ac, all divided by 2a. Go ahead and write that down again. X is equal to opposite of b, plus or minus the square root of b squared minus 4ac, all divided by 2a. There are several songs that you can sing that help you memorize this. And in class, if you're nice to me, maybe I'll sing you one. But I'm definitely not doing it on YouTube for the whole world to see. Bad enough I got to do it in front of a bunch of teenagers, grown men singing goofy songs of quadratic formula. I ain't doing it on YouTube, I'll tell you that right now. Anyway, so quadratic formula, right, where A, B, and C are all coming from this here, the quadratic equation there. Couple other things that go along with this. The discriminant. The discriminant is a certain part of the quadratic formula. The discriminant is b squared minus 4ac. That is, the discriminant is the part of the quadratic formula that's inside the square root. Notice there is no square root. I omitted the square root. Now, if the discriminant is positive, what that means is that there are two real solutions. There are two real solutions. If the discriminant is 0, that means there is one real solution. And if the discriminant is negative, that means there are, I'm probably saying, no real solutions. And while you are correct, there are no real solutions. However, there are, in fact, two imaginary solutions. All right, so the discriminant can tell us a little bit about this parabola before we even solve it or graph it or anything else. First of all, I keep saying the solutions, and you might recall earlier this chapter we said solutions were the same thing as there's another word that we equated it to. Solutions are the same thing as roots, which roots are the same thing as zeros, and zeros are the same thing as intercepts. Now here's the thing, all these ways we have to solve, when we solve, what we're actually finding are the x-intercepts, the roots. Now, if we were to graph something where the discriminant was positive, the graph is going to look something like this. It's going to be a parabola, and it's not necessarily going to go and open up or anything, or the vertex is going to be in quadrant 4, but it's going to have two real solutions. It's actually going to cross the x-axis twice. If the discriminant is 0, what this graph is going to look like, and again, doesn't necessarily go and open up. Oops. It's going to have one x-intercept. It's going to cross the x-axis once. Or the parabola is going to be, what was that word in geometry? It means that it just touches it once. Starts with a T. Ends in tangent. There you go, tangent. And then two imaginary solutions. Two imaginary solutions, which means it has no real solutions. It's not going to cross the x-axis at all. It does cross the y-axis, of course, but it's never going to cross the x-axis. So let's do one example, and then you're going to do 20 of them or whatever in your homework. Let's go with negative 2x squared equals negative 2x plus 3. So, remember, quadratic formula, in order to do it, it has to be in the form 0 equals ax squared plus bx plus c. Or, of course, it could be ax squared plus bx plus c equals 0. Either way, doesn't matter. So, in this case, what I'd recommend doing, I don't want to move two things. I'm just going to move one. I'm going to move this negative 2x squared to the right side. So now I'm at 0 equals 2x squared minus 2x plus 3. So, first thing, actually, before we dive into quadratic formula, let's do a couple other things first. One, what is the discriminant? What is the discriminant? Let's find that first. So, discriminant is going to be b squared. Now, I always put parentheses around b. No matter what, I put parentheses around it. B squared, so this is going to be negative 2 squared minus 4 times a, 2 times c. So b squared minus 4ac, this is going to be 4 minus 4 times 2 is 8, times 3 is 24. 4 minus 24 is negative 20. So I know that my discriminant is negative 20. That brings me to question 2. What does that mean? What does that mean? Well, if the discriminant is negative 20, what does that mean? That means that our solution is going to have two imaginary solutions. Two imaginary solutions. That brings us to question 3. What are those solutions? What are those solutions? Well, this is where we run the quadratic formula. So, x is equal to the opposite of b. Remember, I always put parentheses around b. And it's for this reason. Notice I keep saying the opposite of b. I don't say negative b, because in this case, b already is negative 2. So when I say the opposite, that's eventually going to become positive. But for right now, we're just going to plug it in and check it out. X is equal to the opposite of b, plus or minus the square root of b squared minus 4ac. Man, that sounds like a bummer to do. hey, wait, we already know that. What's inside the square root is the discriminant. So there's a negative 20 up inside there. All over 2 times a, which is 2. All right, so let's simplify this a little bit, shall we? So we got 2 plus or minus. What does the square root of negative 20 break down to? The square root of negative 20 breaks down to 2i root 5. The whole thing divided by 4. All right, now you look at the 3 coefficients or constants. So here I got 2 plus or minus this next 2 divided by this 4. We're looking at those 3 things. If you're going to simplify this fraction, all 3 of these numbers have to have something in common. They all have 2's. So our final answer here is going to be 1 plus or minus I root 5. The whole thing divided by 2. Right? I would also accept 1/2 plus or minus I root 5 divided by 2. I would accept either of those solutions. Where are we at? That's enough. So go ahead and practice and bring your questions later. Smith out!